So, good morning. So, we're going to start our first lecture video for the subject computer engineering and drafting and design. Now, before we get into our first topic, which is about flowchart, and then we're going into the black diagram. Let us first try to know why we had to start with the flowchart. Why do we have to study about the flowchart if we're just going to do drafting and design printed circuit board? So how is it connected with what we're trying to output? So as computer engineers, isa sa mga important skills natin is how more than how we know we can actually design the machine is how we can lay out and plan it. So um, before any design or before any building or kahit ano yung i-create natin, it is an important rule to first lay out something before you actually build it, before you actually create it, or before you actually put it into an output. Even yung mga dating gumagawa ng computer systems and computer machines, kahit si Charles Babbage, di ba? Ang una niyang ginawa ay hindi agad i-build yung system na, nakaisip ako ng ganito, I will build it. No. Before he did that, ang unang ginawa niya is to lay out what computer system or the design of the machine that he will be creating. Kaya nga, naiwan yung pag-build niya, um, ang na-create niya is yung concept, yung drawing, at yung idea of what machine he is thinking of. Kaya though hindi niya natapos yung pag-build ng system, it was created even after his time. So isa sa mga importanteng kailangan natin malaman as computer engineers is how we can actually build the plan first. Kung mag-draw it muna or design it muna before we actually build it. And that is one thing that we're going to learn in this subject. And aside from that, we we should also know how to understand and to read those designs. So more than knowing how to create it is importante din na alam natin kung paano natin ma-design o paano natin mababasa na kapag merong ibang nag-design ng computer na to or ng system na to, kaya mo ba itong gawin? Alam mo ba kung anong ibig sabihin ng mga lines na to? Alam mo ba kung anong ibig sabihin na magkakonekta yung resistors and then this component? So, that is one thing na kailangan nating malaman. So, in the succeeding lessons, we're gonna know how to read the schematics or a schematic diagram para mas alam natin kung paano natin muna i-design, paano natin babasahin yung pagkaka-connecta, the interconnections between what we should print on the board. And I assuming that at this moment, may naiisip na kayo kung ano yung maaaring natin i-design din sa PCB. So, later on, hopefully, we can create or ang output natin ay isang printed circuit board na based from the designs that we create and based on what the computer system or what the machine that they wanted to do has to do. Okay. Now, bakit flowcharts? Balik tayo dun sa topic na bakit kailangan natin pag-aralan yung flowchart and block diagram. Now, the flowchart and block diagrams are one of the necessary tools that we have to provide at least in order for even non-computing peeps to know what's going on here. Ano to? Para saan to? Bakit may ganito? Anong ginagawa nitong gagawin mong computing system or computing device? So basically, this flowchart and block diagramming is for the client side or a much easier readable format na sa kung anong kayang gawin nung i-design natin sa ating mga PCB. So, let's start with getting into the stuff of knowing what a flowchart is and a block diagram. Now, a flowchart, I know na madalas nyo na encounter yung flowchart even in different concepts. We use flowcharts in software development. We use flowchart in depicting a process even in simple instructions. So, flowchart is quite a famous diagramming or graphical method in lots of subjects or lots of topics. So, what can the flowchart show? Bakit siya ginagamit or para saan siya ginagamit? A flowchart or a workflow diagram, as we call it um, for other terms, is a kind of a representation and diagramming method that shows the flow of the process. So, naipapakita niya kung paano yung takbo ng proseso. So, it dictates what happens now at this point, then what will happen next. So, it was a good representation method to show how the whole process or how the whole, sabihin natin yung sa machine, how the whole machine works. Like, I turn on this one and then it will need an input from the user, then the input from the user will be analyzed and compared to the set parameter, and then the parameter should adjust into something, parang ganun. So that is what the flowchart wanted to represent in terms of siguro sa side natin dun sa pag-build ng machines and pang-build ng computer systems. The same way sa software development, di ba? So the user inputs username and then the password, then it checks from the database. The database will throw um, the needed information and sorts. So a flowchart, the the symbols that we're going to use in the flowchart, actually, kung makikita nyo, ang daming, alin kaya itong gagamitin natin? Iba-iba yung sinasabi nila na symbols na ginagamit sa flowchart. Now, it depends upon what type of workflow or anong klaseng process ba yung represent mo. So, in our case, what I will present to you is a bit of something that we can use technically for our CV design and something for our software development side. Since what we're expecting is when we build the system, it's usually a combination of the hardware and the software interconnections or communications. So a flowchart resembles a block diagram, and we will discuss block diagram kung ano naman yung difference niya. If we are going to choose between the flowchart and the block diagram, what's the difference between them? How should we evaluate what to use between the two kinds of representations? So let's get into uh, the different symbols used in flowcharting. So I have defined here several shapes that was used in flowcharting, and this represents um, a certain process or a certain step and a certain condition in the process. So first, and I know some of you may have been, or maybe most of the subjects you've encountered this one, but let me just repeat it. So an oval is sometimes we use circles or sa ibang flow charting yun, but here let's use oval. So an oval designates or represents the end or beginning of the process or the flow of the device that we're gonna use. So it shows the end and the beginning of the process. A rectangle is just the basic step kung ano yung statement na kunyari input 5 or user input age. So yung basic command, yes. A step and or a basic command that we wanted the process, yun yung next process or next instruction ay perform din sa process. So that should be put into a rectangle. So ito yung usually makikita natin rectangle kasi basically the algorithm or the instruction that the process flows are commands na pagkatapos nito ito ang gagawin niya, then ito yung gagawin niya, then ito yung gagawin niya, then ito yung gagawin niya. However, it's not always commands that lets the process flow. Hindi lang command ang bumubuo sa isang process or sa workflow ng isang computing device. And we'll browse later kung ano-ano pa yung maliban sa mga steps and commands and instructions, ano pa yung maaari natin mapili para maisasanga dun sa ating flowchart. Now, the next symbol here is an arrow. An arrow is just basically the one that's directing where to flow. Siya yung mismo nagda-drive, parang ganun, nagda-drive kung saan tayo pupunta sa mga symbols na nakalagay sa ating flowchart. So, indicates directional flow. It used to guide us or the viewer or the reader of the chart or the graphical representation along the path of the flow chart. Now the diamond here is representing the decision making that if there is a decision making that is needed in our process. So kung meron kang step na, or not, it's not actually a command. Kaya nga sabi ko, iba yung command. Sa rectangle yun. So kung meron kang question suddenly, is it a yes or a no? Yeah. When it comes to decision making, we use diamond. Say, if the parameter is larger, go here. If the parameter is bigger, is smaller, go here. So something like that. So a diamond doesn't represents the decision making that we have to perform during the process. Now here, this one's some of the symbols na are related into software development, and I just included it that because I am assuming that when you create your thesis, there is a backup um, software development that you have to create. So document. So a single and multiple document icons show that there are additional points of reference from your flowchart. So you might use it to indicate, like create an invoice, review testing paperwork. Ibig sabihin, meron kang expect na neither an input but another references that you need for the process to flow. And then here, we use this one as database if you are going to connect your system into a database and a data storage. So data storage data gets stored from here. It doesn't necessarily mean it's a database. When data storage means it's like a hard disk drive, it's a flash drive or something like that. Yeah. So input and output. So when we say input and output symbols, when we are yielding or asking for an input, then it is like this one. Kumbaga, if we need an interaction or if the process or step involves na the user, then we use this one. So input, kasi kailangan natin ng input from the user or input from another entity or another system, then we use this rhombus. Okay. Now, this symbol, this inverted triangle, symbolizes merge. So merge is a connector that makes it easier to connect flowcharts that span multiple pages. So a merge is something that we use kapag yung flowchart natin ay masyadong malaki or too big to fit into one pages. So a merge means a connection that this part or this page of flowchart is connected into or merge or kumbaga isang flowchart lang siya, member siya ng isang flowchart. Now, subroutine. What is subroutine? It indicates a sequence of action that performs a specific task embedded within a larger process. So, ibig sabihin, if it is a subroutine, it is a sub-process of that flowchart. So, parang pinbreakdown mo yung larger flowchart or larger process into smaller ones, and this one is a member or a sub-process for the larger process that you are representing into this one flowchart. And if you stated this one, kunyari ito, let's say, adjusting temperature ang pangalan nito. Tapos meron kang flowchart of sabihin natin yung aircon technology kasi may karap akong aircon. So, sa aircon workflow, meron ka biglang nakalagay na subroutine, this one, this rectangle na parang may outline pa. Tapos nakalagay mo ay adjusting temperature. Ibig sabihin, you don't need to include in the flowchart the flowchart for the process or the process on how the aircon adjusts the temperature. Meron kang separate flowchart dyan na gagawin. Kumbaga, kung kinocall natin kung ano yung another flowchart or another process just to make it or make yung main na flowchart smaller para hindi masyadong malaki yung flowchart na babasahin. You can subdivide it and call it using this one. So loop limit indicates the point at which a loop will stop. So this is when you have or when you indicate that your your process has a loop on it. So kung meron kang magiging paulit-ulit na step na gagawin, a loop limit states when will this paulit-ulit na step stop. Now, delay indicates a delay in the process. So, we might use this one, lalo na kung kailangan natin ng proper timing. Kung meron tayong mga timing na ina-adjust dun sa ating PCB or dun sa circuitry ng board natin. So, kung meron tayong may involved na timing processes, we need delay. This delay symbol. Now, sort symbol, usually ito naman gagamitin natin kung meron tayong database symbol or if we are managing a lot of input from the user. So usually software side to. It indicates a step that organizes a list of items into a sequence or set based on some predetermined criteria. So if we use this one, it means we are to arrange what is coming in or what is the input from the user. So this one is display. Again, from the software side of development, display indicates a step that displays the information, whether it is an output or whether it is a raw input from the user and you want to just display it or display a status. So off page, the process continues off page. So this one is another thing that we can use pag masyado ng madami or masyadong malaki yung software na hinahandle natin. Now for the next page, we have here an example of a flowchart. So this is just a simple flowchart and let's see what it can do. So sa ating flowchart, sabi niya, this is a start symbol. The first step and first instruction that we will face here is enter temperature and current parameter. So actually we can use an input symbol right here, right? So let me just So since it yields an input, we can actually correct this one or revise this one and have it like this one kasi meron tayong hinihinging input from the user. Yeah. Then, read input data, yun yung flow. Pag nakapag-input na yung user, we read the input data and then there's a decision here. Actually, what we usually do is we include it inside this one. Now, if the input data value exceeds the parameter, anong gagawin? It displays, if it exceeds, it displays the parameter on the LCD, tapos magkakaroon ng alarm, mamamatay or magta-turn off yung machine o yung system. Kapag nag-display siya, i-check niya, is the fault acknowledged? Kumbaga, napansin ba or nagawan ba ng paraan? If yes, alarm unit turn off and magre-reset. Magre-read ulit siya ng input data. Pero anong mangyayari kapag hindi naman nag-exceed yung value? So what it's gonna do is read input data and it will be looping. So ibig sabihin, every time, since it's about temperature, I think this one's an aircon. So every time it receives an input temperature or yung current temperature of the room or the surrounding, it will read and read and read and read and read. So ang purpose lang niya is nag-a-alarm lang siya kapag nag-exceed na dun sa set parameter or sa set temperature mo. Okay. Now, yep. Let me just fix this one. So here, I just translated what the flowchart into an English statement of the algorithm. So, yeah, I just have stated it right here. Hindi na natin uulitin. So, what does the flowchart suggest? So, from the flowchart given above, we can define a system that is defined as a temperature alarm system. The alarm turns on if the temperature input exceeds its acceptable value. If not, it continues on reading and reading and reading and functioning. So, punta na tayo naman sa next natin na topic, which is the functional block diagram. So, what is a functional block diagram? So, this is what you will most encounter kapag medyo technical yung magiging kausap mo. So, flowchart is good if who you're presenting with, yung pinapresentan mo ng iyong design is not much of a technical person or hindi masyadong computing person. Kasi hindi niya masyadong magigets yung mga technicalities, the schematic diagrams, no, he will not, at least it's a burden and it's too much stressful para basahin or unawain para sa kanila. So a flowchart would be a good representation diagram or a representation tool para mas maintindihan nila in a way na kung paano nag-work yung system. Now, there's another diagramming method or representation method that we can use, pero ito ay mas magagamit na natin dun sa medyo computing professional din. So, it's called the block diagram. And we might want to use it kung tayo-tayo rin lang naman yung nag-uusap kasi sa flowchart. Ang flowchart kasi masyadong matrabaho, masyadong detailed yung process niya to the point na gusto mo kasing ipaunawa din sa client how would likely flow. Pero we can actually minimize or reduce or simplify it. Kaya lang medyo more technical ang mga description. Pero simple lang yung magagawa nating diagram at representation. So it was a helpful tool if you wanted easier design, hindi matrabaho, madali lang gawin, pero naiintindihan. It can represent what you wanted to represent. So we call it a block diagram. So actually we're going to encounter in our design what we're going to encounter is a block diagram, a schematic diagram, and we will learn that later. So, a schematic diagram includes every component. Ito yung mas detalyado na mas kailangan naman ito nung magde-design na mismo ng system kasi it's something that you cannot see in a flowchart and you cannot see in a block diagram kung paano na ang layouting nito, sino na yung magkakonekta. So, you wanted this to happen, paano mo sino-sino sa tingin mo, anong voltage sa tingin mo ang kailangan para magawa natin ito dun mismo sa actual na pag-print na natin sa printed circuit board. So, we need a schematic diagram at that. But the block diagram, we need that to at least give us information on what, kumbaga, siya yung first step bago tayo makagawa ng schematic diagram para alam natin kung anong in-layout natin dito, ano ba yung gusto natin mangyari. So a pictorial diagram is a layout diagram that shows the actual physical arrangement, yung mismong physical arrangement dun sa mas kamukha siya nung mangyayari sa breadboard natin or sa circuitry natin. Pero masyado siyang hassle. Mas mabuting gumamit tayo ng schematic diagram that has the symbols in it kung kaya naman ating unawain. So when you troubleshoot an unfamiliar electronic circuit, you usually start with a block diagram to find where the trouble originates. So it is helpful too that we have a block diagram in order for us to know alin ba dito, nasaang part yung kung ang mali ay yung power supply part or power supply side, saan block ako pupunta, saan kaya anong connection kaya ang nagkaroon ng fault. So you'll refer to the schematic diagram to find the faulty component in relation to other components in the circuit. So block diagrams, on the other hand, are the easiest form of diagram to draw and read, kaya mas madali siya na ipasa sa ibang tao aside from the flowcharting. So block diagram are the first step in the design process of a system, though we can choose between the flowchart and block diagramming. Dahil mas mabilis nga, mas madali para sa ating gamitin ang block diagram, only that it's more technical side. So it is the first step in the design process of the system. So the engineer or designer of any computing system or any process uses a block diagram to describe a particular system with all its related units. So ito ay system for the power, system for the regulation of the temperature. So we divided it into different systems that consist our whole computer system. So the function and purpose of a system can be more readily conveyed and understood when a block or flow diagram or flow chart is used. So in electronics, we use the block diagram where it is unimportant to show a specific circuit connection kapag hindi naman yung kailangan natin. Kaya nga first part siya ng design kasi hindi pa at that point hindi pa natin kailangan i-state kung sino yung magkaka-connect, kung ilang resistors o ilang capacitors ang kailangan natin o ilang ICs ang kailangan natin for the system to work. So what we wanted to do at that part or that point is just state na merong ganito, may unit na ganito, may power supply unit, merong ganitong unit, merong ganitong unit. So the interconnections are still not needed at this point. So mas madali siyang gawin. So basically, this block diagram was or represents stages, substages, units that compose the computer system. And it will make up the total computer system that you are trying to design. So what may the blocks contain or represent? So each blocks, when we say each block, the rectangle one that may represent a stage, a system, or a functional unit. So each block may be individual modules, units, or removable portions of a total system made up of multiple sections. So from that rectangle that we will be creating, doon tayo pwedeng mag-create ng schematic. Ano ang connection nito? Tapos connect natin ano ang connection nito sa ganito. So there we can create a further schematic diagram for that one block diagram or for that one unit. So it can also represent a complete chassis or unit or something small, for instance, a group of integrated circuits. It can represent it, pero hindi nga detalyado as schematic or as the pictorial diagram. It can be established on several levels. They can be used to describe a functional relationship between major units. Example, we have the sequence of operations for a stereo system. We have turntable, to tuner, to amplifier, to speaker, and then within that amplifier, we still have a more detailed specification kung gagawin natin siyang schematic diagram. Sa speaker, meron pa tayong maaaring magawang more detailed connection and interconnection for the schematic diagram. So they are divided into functional units, and that unit represents a deep and even more specific and detailed diagramming in terms of a schematic. So a block diagram also describes the relationship of specific subunits. So, maaaring siya ay meron pang, kung i-breakdown natin yung isang functional unit of a block diagram, may magagawa pa tayong isa pang block diagram. So, in the computer industry, block diagram is used to describe the organization of the computer system. Sabihin natin computer architecture. So, we have the memory unit, then the ALU, the CU, the input unit, and the output unit. We can show the connection between them. It can be represented via a block. And then the memory unit itself is yet another block diagram kung hahatiin pa natin. So it can show the organization of the computer systems. And in computing industry, this could represent a series of complicated circuits and components if we wanted to break it more into more specific form. So when preparing computer diagrams, we try to maintain a uniform block size to represent similar devices or functions. So we have here a block diagram of a computing device. See, we have here system bus, trans receivers here, decode logic here, but it doesn't mean that it is the actual component that we need. Hindi ibig sabihin may decode logic dito. Ibig sabihin may transceivers dito. There are more for specifications that can or may be included in these separate blocks. So we have here a simpler block diagram. So for an electronic device. So sabi dito AC in, ibig sabihin may dadalhin dito na kuryente, and it might either be going to the fuse or it will go in both the fuse and timing components. And then from the timing components, it will, the next part or the next unit that it will have is adjustable timer. So mula sa fuse, rectifier, adjustable timer. Tapos from the adjustable timer, doon naman tayo pupunta sa transformer. So this is a block diagram. This diagram illustrates a various part of a strobe light circuit. So the input signal enters at left, it's utility AC, and the input AC goes to the fuse or the timing components, and pala, and not or. So goes to the fuse and the timing components. So the top path, pag yung mga pupunta yung part side ng fuse, leads to a diode type rectifier, and the rectifier output passes directly to the three terminal strobe lamp. So meron ditong light terminals. So it's either it goes in the fuse, then rectifier, then the light terminal. And then another path is timing that adjusts. Wait lang. So the rectifier outputs an adjuster. Meron siyang sariling adjuster that provides a variable flash rate for the lamp. So the output from the adjuster goes to the transformer. This one pala, sorry. To the transformer, which provides the remaining two outputs required to operate the lamp. Now this one is another block diagram. This one. So the block diagram shows the power supply that produces several voltage outputs. So ito naman, nagta-transform siya. Meron tayong two transformer here that transform it into different voltages. So it filters it right here. This transforms into 16 and 13 voltage AC. This one transforms it via rectifier into 12. And then this one transforms it into 18. Another rectifier here that transforms it to 18. And one that produces another 12 pero that's a rectifier and voltage regulator. So this is how the block diagram of this one is stated. So makikita natin kung paano maaari, ano yung mga kailangan na units dun sa i-create niya na system. So for our next topic, we will be discussing about the different. So preparation na tayo para sa pagbasa ng ating electronic diagram or the schematic diagram. So we will be discussing about the different symbols that we can use, or at least the most commonly used one for electronic circuits.